Hello friends, welcome back. Let's continue with the differentiation of trigonometric functions and let's try to look into different flavors. We started with simple examples. Slowly we moving towards a combination of trigonometric functions and applying the chain rule on that. So let's have a look at this example. We have to find out the derivative of sine to the power of mx into cos to the power of nx. We have to find out the derivative. So at high level you can observe and you can see that the function for which we have to find out the derivative is in the form of product of two functions. So can I apply product rule there? So the product rule says the differentiation or the derivative of product of two functions is nothing but equal to the first function multiplied by the derivative of the second plus the second function multiplied by the derivative of the first. So if you take, let's write it down. What is our u now? U is equal to sine to the power of mx. What is v? V is equal to cos to the power of nx. Now let's try to apply chain rule and find out what is u dash and v dash. U dash is equal to d by dx of sine to the power of mx. Sine to the power of mx. Now at high level sine to the power of mx, I see it is in the form of x to the power of n. For some time, let's forget that sin x is there. I see that it's like a variable z to the power of m or t to the power of m. I know that if there is a variable n to the power of n, the differentiation is nothing but equal to n, which is nothing but equal to m here, multiplied with x, x is sin x, whole to the power of n minus 1. N is m here, so I will have m into sine to the power of m minus 1x. I hope that's clear. Let me repeat that. D by dx of sine to the power of mx you want to find out. At high level I see I have a function which is a variable. The variable itself is a function, so I have to apply chain rule on that. Let us say this sin x is some z or z. I have z to the power of m. So I know g to the power of m derivative is m into g to the power of m minus 1. That's what I have written here, but g is nothing but sin x. Okay, right. After that, now you know that the variable itself is a function, so you should find out the derivative of that. That's nothing but equal to d by dx of sin x. This is chain rule, right? Okay, so what you got here now? You got m cos x sine to the power of m minus 1 x. That is the derivative of u or sine to the power of mx. Let us see what is the derivative of v or v dash. V dash equal to, in the same lines, d by dx of cos to the power of nx. Now again I can apply the same logic whatever I said earlier. Cos x, let us it be variable, then I have variable to the power of n. At higher level I see a function which is in the form of x to the power of n. So the derivative of that x to the power of n is n into x to the power of n minus 1. So I can say n into x is cos x whole to the power of n minus 1 is cos to the cos to the power of n minus 1x. Okay, this we have. Now after that what I should do? We should find out the derivative of cos x, because the variable whatever we are treating as a variable itself is a function, so I should know derivative of that also. Cos x derivative is minus sin x, so it will become minus n sin x into cos to the power of n minus 1 into x. So we found u dash and v dash. Directly we can go and substitute in the formula. So let's put it in the formula. We will say uv whole dash equal to u into v dash, that is sine to the power of mx multiply with v dash, that is minus n sine x multiplied with cos to the power of n minus 1 x plus v is cos to the power of nx, that I have to multiply with, I'll write it down here, I have to multiply with u dash is, let's put it, cos of nx multiplied with m cos x sine to the power of m minus 1x. Okay, let me just cos nx into m into cos x into sine to the power of m minus 1 x. That's what we have. Now let's try to simplify this. First I'll start here the second term, m cos x into cos nx is nothing but cos n plus 1x. So can I write it as m cos n plus 1x n plus 1 x multiplied with sine to the power of m minus 1 x, then I have minus here, minus n sin mx, sin x will become sine to the power of m plus 1x. How we got it? We got it because we know a power m into a power n equal to a power m plus n. By using that laws of exponentiation, we can do sine to the power of m plus 1 x multiplied with cos of what we are left out with, we have taken care of this, we are left out with cos n minus 1 x. So that's the derivative of sine to the power of mx into cos to the power of nx. We took it as a product of two functions. We separated them. U is sine to the power of mx, v is cos to the power of nx. Now we applied chain rule and find out the derivative of u dash and v dash. After that we have substituted a little bit of tweaking. We have to just simplify, make sure that we have only one term related to sine and cos. We'll get our answer. So let's look at one more simple example. Earlier we have seen the derivative of sine to the power of mx and cos to the power of nx. Now let us say if it is not to the power of m but sine mx cos nx, what will be the derivative? Same logic we will apply. We will say we are in the form of uv, where u is sine mx and v is cos nx. uv derivative equal to u into derivative of v plus v into derivative of u. Let's find out what is u. We know that u is sine mx. What is v? v is cos nx. What is u dash? U dash is derivative of d by dx of sine mx. We know again, we see at higher level sine of some variable, that is derivative of sine x, which is nothing but cos x, but x is mx, so I will write it down as cos mx multiplied with. Now we know the variable which we took it as mx itself is a function, so its derivative is nothing but d by dx of mx, so which is nothing but equal to m cos mx. Since we are in initial stage, we have to be little bit elaborate, but after some time, once you got expertise with this, you will directly write down like this, d by dx of cos nx. So you will say derivative of cos is minus sine, so you can write it as minus sine nx, and nx derivative is nothing but n, so you will directly write it as minus n sine nx after some time. Now let's put it in the formula. We will say uv derivative is equal to u into v dash, that is sine mx, into v dash, that is minus n, into sine nx, plus v is cos nx, multiplied with u dash. U dash is m cos mx. So I can write it as m cos mx. Let's simplify this. This is equal to, if you just put them in one order, positive first, m cos mx cos nx, I will have m cos mx cos nx, then the minus will come out. I'll have n, the constant term. After that I'll have sine mx sine nx, sine mx sine nx, sine mx sine nx. It's not clear. Let me give a space there. Sine mx sine nx. That's the derivative of sine mx cos nx. Let's do one more simple example. Let's look at this example. We have to find out the derivative of log of secant x plus tan x. Now at high level I see log of some variable. So can I take this secant x plus tan x as one variable? I have nothing but derivative of logarithm of some variable. Or I know that logarithm of x is equal to 1 by x. So this is equal to 1 by x. X value is nothing but secant x plus tan x. Secant x plus tan x. After that I have to multiply with, I know I have taken this as a variable, but itself is a function, so I should find out the derivative of that. That's what chain rule says. So I should go for d by dx of secant x plus tan x. Now this is nothing but equal to 1 by secant x plus tan x multiplied with, I have to find out the derivative of a function which in turn is addition of two functions. So now I know that I can write them as separate functions. So I can say d by dx of secant x plus d by dx of tan x, which we have seen already how I can do that. Now let's go to the next step. In the denominator I will have secant x plus tan x, but in the numerator derivative of secant x is secant x tan x, and derivative of tan x is secant square x. So if you observe, you can take secant x common because I have secant x in both of the terms. It will become secant x into secant x plus tan x divided by secant x plus tan x. You can see that I can cancel the term secant x plus tan x in both of them. I will have secant x. So the derivative of logarithm of secant x plus tan x is equal to secant x. So in the next session we'll continue with examples which focus more on chain rule, where we have to apply chain rule up to 2 levels or 3 levels. Those type of problems we'll see, so that we'll get little bit comfort with respect to chain rule problems. So I'll catch you in the next session. Thanks for your time. Bye for now.